Hello everyone. In the second lecture of bitwise operation in Java, where we are focusing on negative numbers in Java. From my previous lecture, you have understood how positive and negative numbers are stored in Java. In this lecture, we will see its usage while performing bitwise operators in Java. After this lecture, you will be able to understand and perform bitwise operations on negative number in Java. Also, you will be able to identify the difference between right shift and unsigned right shift bitwise operator in Java. There are 7 available bitwise operators in Java. In this lecture, we are going to discuss about bitwise complement, right shift, and unsigned right shift operator in Java. While performing bitwise operator on negative numbers in Java, there are following steps which we have to follow. If number is negative and you have to perform bitwise operator, then first find the 2's complement of that number, because all the bitwise operation will be performed on machine level code. And why we are performing 2's complement we have already discussed in the first lecture, after which we perform the bitwise operation. After performing bitwise operation, if you are getting positive number having MSB is 0, then this is your final answer. It is because if your number is positive, then your logical code as well as machine level code is equal. Both of them are equal. Otherwise, if you are getting MSB as 1, then it means your machine level code as well as your logical code are different. So in that case, you have to convert your machine level code into your logical code with the help of 2's complement. And after getting the logical code, you can convert it into your decimal number. Now, the first we'll discuss about not bitwise operator in Java. It is used for flipping of the bits. It is also known as binary ones complement operator. So here in this example, what we are doing, we are performing not operator on 1. So if we are performing not operator on 1, we will get 0. Similarly, with the case of 0, if you are performing 0 not operator on 0, then we'll get 1. Now we'll perform bitwise not operator on -30. Therefore, it will follow the same steps we have discussed in my previous slide, where initially decimal number will be converted into logical code, and after performing 2's complement, we will get the exact machine level code of -30. So now we can perform bitwise operator and got the machine code by flipping of the bits, but here we are getting 0 on the MSB bit, which means now logical binary code and machine code are equal. Hence, we can directly convert it to decimal number and get the answer as 29. Now, the second operator which we are going to discuss is signed right shift operator. It is also known as right shift operator, as well as we sometimes will use signed right shift operator. So here in this example, we can see we got a positive 4-bit number So we have to perform right shift operator of one bit. So if the number is positive, then it will append 0, but if the number is negative, then it will append 1 on the right hand side of MSB. So here we are shifting one bit. So what it will do, it will flush out the value which is available on the LSB. So here we are flushing out only one LSB bit. So it means the one bit of LSB will be flushed out. So the output which you will get over here is 0011. Now we'll perform the signed right shift operator on -30. So in this example, num1 is negative and performing right shift operator on 1 bit. After performing the same steps, we got the answer, but now it is negative. So the machine code which we are getting it in the fourth step, it is negative. So in order to find out the exact decibel value of that machine code, again we have to perform this two's complement, because for negative numbers, as I have already discussed, machine code as well as logical code are different. So in order to sort out, we have to perform two's complement on that, and then we'll get the answer. So if we are performing right shift operator on -30, then we'll get the answer -50 if we are shifting just one bit place. Now, in the case of unsigned right shift operator, there is a minute difference between unsigned as well as signed right shift operator. The difference is that in the unsigned right shift operator, the MSB bit is 0. So if you are performing unsigned right shift of the operator, what will happen? It will unset the MSB. So if you are having any negative number, so in the case of negative number, what will happen? Your MSB bit is always 1. So what it will do, it will unset that bit. So it will become, after performing unsigned right shift operator, it will unset that bit, and then you will get the 0 over there. Therefore, for positive number, there will be no difference on those two operators. But for negative numbers, you will find the difference. So here what you are doing in this example, there are 4 bits, so and one represent it is a negative number. So after performing unsigned right shift operator, you will see on the MSB bit, that is your signed bit, the bit 1 is unset, and it means you are getting 0 value over there. While whatever the operation you are perform on right shift operator, the same operation will be followed over here. So for in the case of -30, so if we are performing this unsigned right shift operator on the same number on which is -30, then in that case, first what we have to do, we have to convert it into logical binary code. And after logical binary code, because this is a negative number, then we have to perform two's complement. So then we are performing two's complement. Then at the end, after performing this unsigned right shift operator, the only difference which we have seen over there is we are unsetting the MSB bit. So now the machine code which you are getting it in the fourth step, it is positive, hence the logical binary code machine code are equal. That it means now we can directly convert it into decimal number, hence your output is 214748363. While this is the difference between signed and unsigned right shift operator, so the only difference which you will find it over here is in the fourth step. So in the fourth step, you can see in the assigned bit, the MSB bit is 1, while in the case of your unsigned, your MSB bit is 0. Just because of the minute change in this bit, you are getting different answer. So for the signed bit, you are getting minus 15, but while in the case of your my unsigned right shift operator, you are getting a very large number. Hope you have understood bitwise operation on negative number and difference between right shift and unsigned right shift bitwise operator in Java. Thank you.